Okay, so let's get to the good stuff where I'm going to show you how this actually all goes down, okay? We are going to just look at it without words first, just to figure out how to use the formulas and how everything goes together, okay? Just putting the pieces together here. We have n is 15, that's sample size. The probability of success is 0.6. We want to find the probability of at least 6. So first thing we want to think about is NP and NQ okay? Remember that they both have to be greater than or equal to 5. So for NP, I'm going to take 15 times 0.6, which is 9. Yay, that one works. And for NQ, it's 15 times 0.4, which is 6. All right, so both of those check out, so this one can use the approximation method. Now, this NP that you found is mu. For sigma, we do the square root of NPQ. So n is 15, p is 0.6, q is 0.4. The square root of the whole thing. Let's see, 15 and 6.4, and I get 1.897 gross. All right, so that's sigma. So I have mu, I have sigma. This is the probability of at least 6. So the question here is, do I include the 6? Here's 6. At least 6 means I include the 6 and everything higher. So I'm going to push down 0.5. So I'm going to 5.5. So for the probability of 5.5 or above, I'm going to do my x is 5.5. So to find my z, I do x minus mu over sigma minus divided by, and I get negative 1.85 because z scores are 2 decimal places. Now I'm in a normal distribution, okay? This thing was binomial. I'm changing it to normal, and now I'm going to go and look this up. Negative 1.85, so grab your table. Joe, seriously, grab your table. Negative 1.85 is 0.0322. 0.0322, though, is the area to the left. So I need to, for the probability that x is greater than 5.5, because that's what I'm finding, I need to do 1 minus 0.0322. Which gives me a grand total of 9678. So you can leave it. I think your computer program is going to have you do 4 decimal places. So 0.9678. Yay. I want you to try one. If you need a little help, stop whenever you get to a point where you think you can take it. Otherwise, hit pause and try it out. I know, this one's a little bit different, so it's going to be a tough one. I'm going to just do like this so we can separate our lives here. Alright, n equals 12, p is 0.5. Probability of x equal 9. You remember the fun thing that happened when it was x equals? I had to build an area around the 9. This will be up here. So I'm going to do in between this time. Alright, let's start with, is NP okay and is NQ okay? So NP is 12 times 0.5, which is 6. NQ is 12 times 0.5 again, which is 6. These both check out. All's well. NP is mu, and sigma is the square root of NPQ. NPQ So square root NPQ. I get 1.732. You notice I like decimal places? Yeah, don't skimp. It's always better not to skimp on them. Alright, look where I'm going between. I'm going between 8.5 and 9.5, right? So I actually need to find two z-scores because I'm finding the area between. So I'm going to find the z-score for 8.5 minus mu over sigma, and I'm going to find the z-score for 9.5 minus mu over sigma. Alright, calculate it up. This is 1.44. Z-scores are 2 decimal places. 732? Yeah. This one is 2.02. Alright, hopefully all is well with this business. Alright, I'm going to find the probability that I'm between 8.5 and 9.5. Do you remember what we did with these two areas when we had them? Ponder that for a moment while you're looking up numbers. See if you remember. That was last week. I'm going to go to z is 1.44 on my table, and I get 9251. 9251. And then I'm going to go to 2.02 to 9783. Okay. This is the area to the left, the area to the left. So what do I do with these two? By golly, I subtract them. Alright, 9783 and 9251. I have 0.0532. There you go. This is the probability that x equals 9. Okay, let's do another one. This one comes out of your book. This is number 23. We're going to find the probability that no more than 32 out of 150 vehicles inspected at a service station will fail their yearly inspection and will not receive an inspection sticker. I'm going to hit pause here and tell you that in some states, especially with very large populations like California and New York, you have to go every year and have your car inspected. A lot of that has to do with for emissions. So you have to go get an inspection sticker to show that that your car is in good enough shape to drive in their state. Alright, so that's what that's talking about. One service station's records indicate the probability of a car failing its inspection is 18%. Alright, so let's take a look at what these numbers are telling us. We are doing the probability no more than 32. No more than means, less than or equal to 32. Does it include the 32? Yes. Which means my continuity correction, here's 32, I want no more than, so I need to move over to 32.5. Okay, so I can include the 32. Alright, 150 is my sample size. 18% is P. We're going to assume NP and NQ are okay and keep on going, okay? So for mu, I take N times P. So 150 times 0.18 is 27. For sigma, I get the square root of 150, 0.18, and 0.82. 0.82. For a second there, I thought I said something else. Alright, times, I get 4.705. Good enough. Alright, so for my z-score, I have my x, which we rounded up to 32.5, minus mu over sigma. Nice. Oh. Do that again. Minus 27, divide. Okay, if I didn't have any, oh, this is z. Z's are rounded to 2 places for our table. Alright, 1.17. This is to the left, so I'm just going to use what I get. So go to 1.17 on your table. I have 0.8790. Okay. So he's in the wrong spot. That's alright. Okay. One more time with these. Last one. Again, this is number 29 in the book. We're going to find the probability that 125 out of 200 people are overweight. Estimates show the probability of being overweight is 65%. Can you find x and which way you're going to have to go? What is n, p, and q? Find mu and sigma, and then find your z, and go look it up. Hit pause and try it out. This one is exactly 125, so we're going to need both. You're going to go between. Okay? Alright, if you were unsure, now hit pause and go. Alright, mu is n, which is 200, times p, which is 0.65. 130. Sigma is the square root of 200 times 0.65 times 0.35. That is 6.745. We are going to find two z's. One of them is 124.5. The other one is 125.5. Since we're going between, we have to include both. Alright, let's go find those two z's. This one is negative 0.81. Oh, this is z's. 82. How many times am I going to do that, right? Alright, now for the other one. Negative 0.67. So, yeah, I drew it on the wrong side. Alright, let's go find our areas. Do you remember what we do with the two areas when we're finding between? Alright, so I go to negative 0.82. Negative 0.82 is 2061. And negative 0.67 is 2514. Okay. This is 2514 and 2061. To find the area between, I need to subtract them. So let me write this all nice and mathy pretty, okay? So the probability that it's between 124.5 and 125.5 from our continuity correction is the difference between those two. So .0453. Alright, I am hopeful that I had no typos along the way, because I didn't have you there to yell at me, tell me that I had typos. Please be sure that you have put the continuity correction on your formula sheet. I lost it. Here we go. But you have your continuity correction on there so that you remember that you have to move 0.5, okay? And this homework assignment, I'm going to have you just go to the Hawks system and do it. The benefit is that you will be able to know right away if you're doing it right, and it'll give you a second chance. So let's say that you get through it and you did them all wrong, you were having troubles, you had to keep looking for help. It will do a second chance. So you do need to score 80% or higher for it to let you move on. But I'm going to send you out some information about all of that goodness too, okay? All right, good luck, guys. We'll talk to you on Tuesday at 2 o'clock for our regular meeting time. Have a good day.